Hello everyone, and welcome to video 4 in my series of how to build a Redstone CPU. So in this video, we're just going to be improving on the design that we built last time and making it more expandable, more easy to understand. So let's begin. I built this about 5 minutes ago actually, and I realized that I didn't even have the game in full screen, so the video came out pretty bad. So I'm actually rebuilding it now, and here we go. I left a few things just so I could remember the spacing easier. So this is actually the bus for the CPU instructions, the opcodes, and this will be a binary decoder right here. And this is the inputs, the binary inputs that would come from memory or whatever other location you had in mind for them. Now, I'm taking the inverse of this one, and you'll see why in a minute, because I'm going to have to knot them before I put it into the actual gates, the logic gates. So, I built this in the wrong spot again. I actually did that in the last video as well. I need room to put this input line right here, and I didn't leave enough room, and so it just didn't work. So you have to build it out far enough that you can get the lines working correctly. And you do need to put a repeater right before the start of your line, otherwise you're going to run out of space pretty quick. Because we are using, I think, 4 blocks per logic gate worth of redstone, so you do need to make sure that it does last long enough for it to... Let's leave them both on so that way we can test it. So 4 times 4 is 16, which is the strength of a redstone signal. So you see it doesn't reach right here. And I think we're okay, but I'll have to see in a second. Because of the positioning of these repeaters, the strength should go to the same position. So it does. Good for us. Okay. Now to begin building. We're gonna pull this line out, go over 4 spaces, just keep doing it. 1, 2, 3, 4. There should be 3 spots between each one. I don't know if I made that clear. Then, in between these lines, on these blue wools, you're going to put a torch. And this is where we're taking the inverse of the inverse. So we're taking the actual output of the torch, and we're going to put that onto a redstone right below the torch. And what that'll allow us to do is make sure it allows us to stack these neatly and bus data from the same position on this axis. And so you could actually stack data pretty efficiently, and it'll be transmitted efficiently as well. So let's go ahead and put repeaters on all these so that we know that whenever it goes into the logic gates, it's getting a fresh, strong signal, because that can matter depending on the logic gate. So let's take out all these. Okay, so let's start building our logic gates. We're going to start with the AND gate, as usual. I'm just going to place the blocks, or I'll go ahead and finish them now, I guess. Okay, there's that. OR gate. XOR. So there's that. And now the adder, which does take a little bit longer, so bear with me. And, if I was smart enough to figure out how to get how to just skip this in my videos, I probably would, but it's probably good for y'all to see it again, just to have a little bit of a refresher on how to do it. I don't know, if you guys don't want it, I can probably take it out somehow. So these are basically the same exact thing we've been building for the other ALUs so far. The only difference being with all these gates is that they're all in a row, which makes them a lot easier to understand in my opinion. And being able to understand something easily is important to maintaining it. Because if you can't understand what the hell is going on, how are you supposed to maintain it? And I've seen a lot of Redstone computers, and a lot of people just start building willy-nilly, and they don't plan it out, and it's just hard to understand because they don't plan it properly. Okay, so logic gates are done. Let's go ahead and, I guess, before we continue, build the bus for the carry-out of the adder. And we can just leave it right there. It doesn't need to be on the ground level. Now, if you were tiling these, you would want this to be on the ground level in the end, just because you would want it to go into the carry-in of this one. So, they need to be lined up and stuff. But let's just make sure it reaches all the way over there first. Yeah, it is these two. Sorry, I'm having a bit of a brain fart. Okay, let's just put a repeater just to be sure. Okay, so there's that. So that's most of the logic portion. Let's just go ahead and build our binary decoder. 4 repeaters for each bit for this configuration. Then the blocks. Now the output will be on this side that I'm on right now, so we're going to kind of put them tilting that way. And it doesn't really matter, but I tend to have it pointing towards whichever way I'm going to have the output going. So okay, so we've got that down. Let's build the rails on top. Okay, so now we've got our binary decoder pretty much done. Notice how I'm not putting a torch on it yet. Now, the reasoning is so for example, 0, 0 is the selector that's being passed in, and this one is the only one that isn't on. So it takes the opposite of what you would expect, and all the ones that aren't supposed to be on are on. So that's why normally we have them going through a NOT gate or a torch. Instead, we want the inverse, because we're going to make an AND gate with the output and the gate that's associated with that one. So in an AND gate, you invert the input and then you put the OR of those two inverted inputs and take the NOT of that OR. So that's a little confusing, especially the way I'm saying it, but that's just how it is. So there's 4 operations. So one of them is going to be based right here. So I'm going to place that, put another one, delete it. Because if I leave one there, it'll block off the signal between here and here, which is bad. So then there will be another one right here. If this doesn't make a whole lot of sense, I'm mostly just preparing for what I'm going to do in a minute. So let's build these rails out. And we're going to have this go to right here. Now, it is worth noting that when it gets to here, it needs to be the inverse of the actual output of the gate. And that's because this is expecting the inverse, because if we put a, hell, I'll just finish this part now. So, build this out. And so we're going to go ahead and build the output section. Finish these rails right here. Then we're going to take the knot of it. Now see, if we took the exact output of this, this is going to be bused up to here. So if we took the exact output, it would say it was true, or 1. But in reality, it should be false, because the AND of 0 and 0 is still 0. So if we take the inverse of this, just to demonstrate, it goes back to off, which is correct. So that's just a little bit of a pointer. I'm also going to put repeaters up here so that we make sure that it has enough strength to get all the way down to the torch, because you do have to worry about signal decay many times. So now we've got one bus down. Let's check it to make sure it works. Okay, I'm actually going to put this invert right here so we can have it be the correct output. And it will reach because we've only got like 5 blocks of redstone. So next would be the OR gate. So we'll go ahead and bust this up. And we're going to have to move it over one. We take the knot of it, like we're supposed to, and we just move it right on over here. We'll put a repeater here just to ensure we have the correct strength. And we'll see we get this connection, which is bad. So we're going to take that out. Put a block here. We're going to go over this line because it needs to be touching this line instead. So there's that one. Next line would be going to there. So basically we're just repeating the same thing and we're just busing right now. So we're going to take this and get it up to there by doing this. We're going to take the knot right here. And a little thing to note about repeaters, it does have to go directly into it. I couldn't have the redstone be on this level and have it successfully go into the repeater. So, just a little word of warning. And we're going to have to expand this out too because we still have one more bus to connect. So, and this is pretty much it. We've got our output fully built, and we've got our buses fully built. So, well, almost fully built, just one more. So we take this, one more over. Okay, let's finish this up and test it, and I'm going to bed after this. Oop, we forgot to take the knot right here. So now that we've taken the inverse of it, let's go. Oh yeah, forgot to pause. Okay, and that is it. Should work completely as intended. So let's just do some quick tests. We've got opcode 00, that's AND. So we take 0 and 1, should be 0. And you can see that line, you can't really see it from here, so I'm going to fly up a little bit, but that line is off. So 1, 1 is on, yay. 1, 0, off, and that's all the combinations. So opcode 1, which is OR, should accept either of them being on. So yes, yes, and yes. Okay, so let's go back to this. Let's change to opcode 10, which is XOR. It's off by default, which is correct. Turn one of them on. We're good. Turn the other one on, and we're good. Turn both of them on, and no good, which is correct. So now opcode 11, which is add. Let's go ahead and put a lever here just so we can test that. 0 plus 0 plus 0 is not supposed to be on. So let's check and see what's going on here. Ah, okay, so see, our signal is decaying before it's getting all the way over here. So we should ensure that it'll work in the future by putting a repeater here. And it looks kind of bad, but sometimes you just have to deal with it. So 0 plus 0 plus 0 is 0. 0 plus 0 plus 1 is 0, 1, which is 1. 1 plus 1 plus 0 is 1, 0, which is 2. If we add one more, we should get 1, 1, which is 3. 1. Oh, so we're still having a problem here. And that would be because I forgot a piece of redstone right here. So we've got 1, 1, which is 3, which means this ALU is completed. So if we, just as a quick overview again, this design is a little bit bigger than our previous design, but you can clearly see what's going on for the entirety of the thing. It's got the logic gates all lined up, the input is bused directly and uniformly across the ALU, and the output is pretty easy to determine just by looking at it. And it still uses the same binary decoder, so it's nice and compact. And overall, it's pretty much better in every way besides size than that one. You can even expand it by adding blocks going out this way and adding more logic gates. So if that's something you want to do, feel free to do it. I think that's it, everyone. Thanks for watching.